All right, geometry friends, here we are, and we're looking at the second section, or the second part, rather, to section 4.3, and we have this proof that we've got to get into. Let me see if I can, there we go, scroll upward so you can see the whole problem. So this is example 4, and we're going to prove that two triangles are congruent. All right, so here's the given information, and this is a really handy thing to do whenever you're proving something. If you've got a figure, mark the figure with the given information. It helps you to see and reason through the proof a little bit easier. So given that DE is equal to GE, and also that DF is equal to GF, and that this angle D here is congruent to this angle G here. And finally, that this angle DFE is congruent to angle GFE. We are to prove that these two triangles are congruent. Now, we know that we have a congruent polygon if all of the parts of the polygon are congruent, right? So if all the sides are congruent and all the angles are congruent, then we can say, all right, you guys are congruent. So we need to prove that. So the first thing I'm going to start off with is the given information. So I'm starting off with the given information, but not all of it. I'm going to start off specifically with the given information about angles. So excuse me. So I have these two angles that I've got that I'm going to highlight the fact that there's a pair of angles that are congruent in both triangles. Now, why am I highlighting just that? I think you know, because I want to now talk about this other angle here. I'm going to put it in green so you can see it. These two other pairs of angles, I want to say that they're equivalent, right? Because this will give me three angles of two triangles being congruent to one another, which is what I need, which is going to help me, and you get it, right? So why? Why can I say now, just from this given information, that angle DEF is congruent, DEF is congruent to angle GEF? How can I say that? I want you to think about it, pause the video, and think if you can go back to where we got this from. We get this from something we worked on earlier called the third angle theorem. Third angle theorem, and that's the theorem that tells us that if indeed we have two triangles and two angles are the same, then automatically that third one is the same. So we get that. We got three angles being congruent. I'm now going to do this next, I'm going to now write the next part of the given, because now if I got three angles, I want to do the three sides, but I don't have three sides. I have two sides, and I'll highlight that. The two sides I have are DE and DE is congruent to GE, and DF is congruent to GF. Okay, so I rewrote that down here, and that's given. And the next thing I want to do is talk about this other side. Well, when I look at this other side of the triangle, we see that they share that side. So I can say that EF, right, segment EF is congruent to itself. Do you remember why this would be the case? EF is congruent to itself because of the reflexive property of congruence. I'm just going to put reflexive property. And I think we talked about this, and it's like reflection, like looking in the mirror, same thing on both sides. Do you remember that? Okay, whatever. So at this point, I'm now happy, drum roll please, please don't do that, but drum roll please. We can say that triangle DEF is congruent to triangle GEF by definition of congruence. Definition of congruent polygons. Because polygons are congruent if all their corresponding sides are congruent, and that's what we proved. All right, I hope that made sense. That is our last example for this section. Let me know if you have any trouble, and trust me, I am looking forward to seeing you. Take care.